You have probably watched dozens of videos about different humanoid robots such as Optimus, Atlas, Figure AI, and others. In this video, we will demonstrate some of the most popular robots' main purpose, why they are being manufactured. We won't get into their specifications or features, just will focus on their functions. Let's start with the most popular one. Tesla's Optimus is being designed to take over the boring, repetitive, and dangerous jobs that nobody wants to do. Imagine factories where robots handle the toxic materials, the heavy lifting, and the mind-numbing assembly line work, while humans focus on the creative stuff. Elon Musk envisions a future where these robots cost less than a car and can fold your laundry, walk your dog, or even watch your kids. But the real purpose goes deeper than household chores. Tesla is building Optimus to address a fundamental problem that is coming faster than most people realize: labor shortages. As populations age in developed countries and fewer young people enter manual labor jobs, someone or something needs to fill that gap. Optimus is Tesla's answer to keeping factories running, supply chains moving, and essential services operating, even when there are not enough human workers to do the job. The long-term vision is a world where physical labor becomes optional for humans, where the economy can grow without being limited by how many people are willing or able to do hard physical work. Boston Dynamics created Atlas for the jobs that would break a human body. This robot is being developed to go into disaster zones where buildings have collapsed, to navigate through rubble and extreme environments where sending people would be a death sentence. Think search and rescue missions after earthquakes, nuclear plant inspections in contaminated areas, and hazardous material cleanup in places where a single mistake could be fatal. The goal is to have Atlas go where humans simply cannot survive. But there is another layer to this. Emergency response teams are often limited by how quickly they can safely assess a situation. Atlas could be the first responder, mapping out dangerous areas, locating survivors, and identifying hazards before human teams risk their lives. In industrial settings, Atlas could inspect oil rigs in extreme weather, maintain infrastructure in dangerous conditions, and handle emergency repairs in environments that would require extensive safety equipment and risk management for human workers. This is about pushing the boundaries of where work can happen and saving lives in the process. Agility Robotics built Digit with one specific purpose in mind: to move boxes. That might sound simple, but think about the millions of warehouse workers who spend their entire shift lifting, carrying, and stacking packages. Digit is already being tested in real warehouses to handle logistics and delivery, working alongside humans to move goods from trucks to shelves and eventually right to your doorstep. This is the robot that could transform how everything you order online actually gets to you. The logistics industry is facing a massive problem. Online shopping has exploded, and the demand for warehouse workers has skyrocketed. But the work is physically exhausting, and the turnover rate is incredibly high. Companies are struggling to keep warehouses fully staffed, especially during peak seasons. Digit is being designed to work continuously without breaks, to handle the repetitive tasks that wear down human bodies, and to fill the gaps when human workers are not available. The vision extends beyond warehouses too. Imagine Digit making deliveries in urban areas, carrying packages upstairs and navigating sidewalks to bring items directly to apartment doors. This could solve the last-mile delivery problem that has plagued the shipping industry for years. Figure built their Figure 03 robot to work in manufacturing and eventually retail environments. They partnered with BMW to put these robots on actual automotive production lines, doing jobs like installing parts and quality inspections. The vision is to have these robots work the night shifts, the dangerous positions, and the physically demanding roles in factories while creating entirely new jobs for humans who manage and work alongside them. Manufacturing has always been about efficiency, and Figure sees an opportunity to make production lines run 24 hours a day without the limitations of human fatigue or safety concerns. But this is not just about replacing workers. Figure argues that having robots handle the most physically demanding and repetitive tasks will allow human workers to move into higher-skilled positions like robot supervision, programming, and maintenance. The goal is to make manufacturing more competitive and bring production back to countries that have lost it to cheaper labor markets overseas. Apptronik's Apollo is targeting a different angle entirely. This robot is being designed as a general-purpose worker that can adapt to multiple industries. One day Apollo might be stocking shelves in a grocery store. The next day, it could be moving supplies in a hospital or working in construction. The key idea is flexibility. A robot that companies can train for whatever task they need without requiring a completely specialized machine. This matters because most businesses cannot afford to invest in expensive custom robotics. Apollo is being positioned as the robot for everyone. It's a versatile worker that can be reprogrammed and redeployed as needs change. In healthcare, Apollo could transport medical supplies, assist with patient movement, and handle sanitation tasks. In retail, it could manage inventory and restock shelves during off hours. In construction, it could carry materials and assist with repetitive assembly tasks. The potential applications are nearly endless. And that versatility could make Apollo the robot that actually achieves widespread adoption across multiple sectors. Unitree's H1 is China's answer to the humanoid robot race. It is being developed for industrial inspection and patrol work. Think about massive factories, warehouses, and facilities that need constant monitoring. H1 is designed to walk through these spaces, identify problems, check equipment, and report issues without needing a human to spend hours doing rounds. It is about efficiency and catching problems before they become expensive disasters. Industrial facilities lose millions of dollars every year to equipment failures that could have been caught earlier. H1 represents a solution where constant monitoring becomes affordable and practical, where robots patrol facilities continuously and use sensors and cameras to detect anomalies that human inspectors might miss. Finally, Unitree's G1 takes things further by aiming to be the most affordable humanoid robot on the market. The goal is to make robots accessible enough that small businesses, research labs, and even schools can afford them. G1 is being positioned as the robot that will let thousands of developers and companies experiment with humanoid robotics without spending millions of dollars, potentially accelerating innovations we have not even imagined yet, democratizing access to humanoid robots. G1 could spark a wave of creativity and problem-solving as more people get hands-on experience with the technology. What makes this moment fascinating is that we are not talking about science fiction anymore. These robots are in testing facilities, working in real warehouses, and being refined every single day. The question is not whether humanoid robots will change our world, but which approach will actually work, which companies will succeed, and what our daily lives will look like when robots are as common as smartphones. Some of these robots will transform entire industries, some will fail spectacularly, but all of them are pushing us toward a future that is arriving faster than most people realize. Write your comments and feedback down. Like and subscribe for similar content. Then watch the next relevant video that will appear in front of you soon.